Hello everyone. Today we're going to be going through slope point form. So that is this equation. So we'll go through that in a moment. Other equation that we have so far is the slope-intercept form. So we have y equals mx plus b. So that's slope-intercept. And this is slope point form. So this is on your formula sheet. So is this. This is on your formula sheet on the back, at the bottom, in the middle. Okay. Before we go through that, I just wanted to show you this for completeness. So vertical lines, here we have a horizontal line, y equals 2. That's the equation, y equals 2. Okay, draw lines x equals -1 and x equals 4 on the same grid. So x equals -1 will be here, and x equals 4 will be there. Pretend that's a little bit more in line. Are vertical lines functions? No, they are not, because they do not pass the vertical line test. Okay, write the equation of the line that is perpendicular to the x-axis that passes through the point 4, 1. So 4, 1 is there. That's x equals 4. So quickly, there you go. Oblique line with a positive slope has an equation y equals mx plus b. M will be positive. So if it is a positive slope, right, that means it goes up and to the right. Slope will be positive. The equation of a horizontal line will be y equals k. So that's y, that's x. So for some k, maybe suppose it's like 5, like that, or maybe 5.5, whatever, as long as k is a real number. And for vertical lines, we have x equals k. So suppose x equals, pretend that's a straight line, x equals like 1, for example. So as long as k is a real number, x equals some real number, will give you a vertical line. Okay, moving on. So a bit of a brain warm up here. Solve this for x. So I'd encourage you to pause the video right now and try that on your own, but we'll go through it right now together. So first thing I'd like to do is probably get rid of the 5 and the 3. So in order to do that, I can maybe get rid of the 5 first. So like multiply both sides by 5 over 1. Right, so on the left side now we have 10 over 3. 5 times 2 is 10. 3 times 1 is 3. And on the right side, x plus 4 times 5 divided by 5, we just end up with x plus 4. Okay, and finally, so x is pretty close, it's almost on its own. I just need to get rid of this 4. So I'm going to subtract 4 from both sides. That's the opposite of adding 4. And so obviously I could do that. Might be an easier way though. You might have done it yourself. So obviously, like, I can do that, 10 over 3 minus 4, but then I have to do fractions. So anyways, I'll show you how to do that. 10 over 3, and if I want to get 4 into a fraction over 3, I need to multiply top and bottom by 3, so that'd be 12 over 3. 10 minus 12 is -2, so -2/3. So that's one way to do it. You can subtract 4 right away there, or if you prefer, what we could do is instead multiply 3 both sides. So some of you may prefer to do this. 3 times 10 over 3 will just be 10. So we have now 10 equals 3 times x plus 4. This 3 needs to multiply both the x and the 4. So just maybe write that because I'm kind of running out of space. So we'd have 3x plus 12 there. And now I subtract 12 from both sides, so 12 minus itself is 0, 10 minus 12 is -2, negative 2 equals 3x, and last I need to divide both sides by 3 to get x on its own, so x is negative 2/3. So there's often more than one way to solve questions like that. As long as you're going through with legal operations, then you should be fine. So moving on, state the equation of the line shown here. So I can get the y-intercept, so b is 3, and I need obviously the slope. So it looks like it goes through there, so to get from here to there I need to drop 2, and so rise is negative 2, run is positive 1, so the slope then is rise over run, negative 2 over 1, or just negative 2. So the equation then will be mx plus b, right? Because we can figure out the slope by looking at it. We have the intercept, might as well use that. Negative 2x plus 3. So there we go. Negative 2x plus 3. So easy to find the equation here because the slope and y-intercept were easy to identify. We had the y-intercept there. We could find the slope pretty easy. So what are some possible scenarios where using slope y-intercept form to state the equation of the line would be difficult? So slope y-intercept form will be difficult to use. For example, if the y-intercept isn't an integer, is not an integer. So if this line crossed through, for example, somewhere like that, like something like that, it's a bit hard to estimate. Is that like 4.2? Is it 4.5? So on. So that would be tricky. Another possibility, or off-grid. So if it was off-grid in like a graph that we're looking at, so if, for example, we had a line that was drawn like that and it was like, you know, intersecting somewhere up here that we couldn't see, that would be a bit tricky to do as well. Similarly, might be a bit tricky if this slope is like irrational. It would be tricky kind of, right, to figure out something like that. So maybe suppose that the only 2 points that it crossed through these intersections was like at 73 and 97. So suppose we had like the slope was 73 over 97, and maybe it crossed through the origin too. So we might be spending a while figuring out what the slope is, because we'd have to count all those grid spaces if we were getting it off a graph. So we'll maybe just leave it at this. So if the y-intercept is not an integer or off-grid, you may be able to think of some other ones, but yeah, anyways. So in order to graph or determine the equation of a line, we either need 1 point and the slope, or 2 points. So if we have this or that in place, then we can figure out the equation of the line. So the slope y-intercept form of the equation gives 1 point, which is the y-intercept, and the slope, right? Y equals mx plus b. So we know this and we know that, and we just put that in there and that in there, and we have the equation. So in the situation where we're given 1 point and the slope, but the point we are given is not the y-intercept, so for example, it's not coordinate 0 comma b, so maybe we're given some point over here, like, I don't know, suppose it's like 2, 3, and we know the slope, right? We need to figure out what the y-intercept is in order to use this version of the equation of a line. So in this situation, we can use something we've seen before. M equals y2 minus y1 over x2 minus x1. So if we have one point and the slope, let's see here. So the slope, right, I can just put in there. And 1 point, suppose, where's that thing? Okay. 1 point I could put in y1 and x1. So we'll see how that works shortly. So again, we've already used this formula. We're going to be applying it to a new situation today though. So we know that the slope of the line shown on the grid above, so up here, right, is -2, right? We've seen the slope is -2. Use this value along with the points -1, 5 and xy on the line and substitute them into the slope formula. So we have xy and -1, 5. So let's put those into this equation. So m, right, I put -2. So -2 equals, okay, I'm going to call x2 y2. I'll call that x2 y2, that's a bracket, and I'm going to call that x1 y1. So everywhere I see a y2 in this, I'm going to put a y in its place. Everywhere I see a y1, I'm going to put a 5 in its place, so subtract 5. Everywhere I see an x2, I'm going to put x, so x, and x1, I put a -1. So simplify this a little bit. -2 equals y minus 5 over x plus 1. If I want to get this x plus 1 upstairs, what I can do is multiply both sides by x plus 1. So multiply that by x plus 1. Multiply that by x plus 1. X plus 1 divided by itself on the right is just 1. And then this -2 needs to hit both of those things. So let's just rewrite that. So next up we'll have -2x subtract 2 equals y minus 5. And I can get y on its own. So I want to rearrange it so that y is isolated. I add 5 to both sides. So do that. Add 5. That gets rid of the 5. So finally, I have, well, that's 0. -5 plus 5 is 0. And I'll maybe just write y on the left. So y is equal to -2x. That stays the same. -2 plus 5 is plus 3. So there we have it. So how does it compare to the equation you found using slope y-intercept in the brain warm-up? So compare this, right, with this one. They're the same. -2x plus 3. So they are the same. So that's slope point form. This again is on your formula sheet. So let's do on formula sheet. It's on the back, it's in the middle, and at the bottom. So this form is mostly used when the y-intercept is not known and cannot be seen, or the precise value of the y-intercept cannot be determined from the graph. So it can generate the equation of a line using the slope and any point. So that is a definite strength, whereas y equals mx plus b, we were restricted to just the y-intercept. So we can't really use this for as many situations as we can with this equation. Okay, so let's try a few more examples. So we're given the slope and one point that is not the y-intercept, so obviously if it's not the y-intercept we can't use this, so that's out of maybe contention. out of consideration, whatever. So we can't use that, but we can use this if we have something that is not the y-intercept. So this is the point slope form. Point passes through 3, -4, and the slope is 2 over 3. So 2 over 3 goes there. That's pretty straightforward. X, y. So 3 links up with the x, so I'm going to subtract 3. So everywhere I see an x1, I'm going to put a 3 in its place. Subtract 3. And everywhere I see a y1, I'm going to put a -4. Now, if we subtract -4, that's the same as adding 4. So this will be y plus 4 on the left. So y plus 4 equals 2/3 x minus 3. Try another one. 1/4 is the slope, so 1/4 goes there. X, y. I guess I don't need brackets for the left side, but I'm going to do it anyways. X-intercept of -5. So that means, what's the coordinate? Maybe pause it and think, pause the video and think, or write down what it should be. So that'll be -5, 0. So my y value here is 0, so I just subtract 0. And my x value would be -5, so subtract -5, right? I put -5 in for x1. If I subtract -5, it's the same as adding 5, so x plus 5. Or y equals 1/4 x plus 5. Good. Okay, next, that's the slope. So -5/2 goes in for m. Go x minus 1. And y subtract -6. Y subtract -6 is the same as adding 6. So notice it's sort of the opposite sign, right? So subtract, if this is a negative, this becomes positive. This is a positive, that sticks negative. Alright, graph line A from the question above on the grid and label it. So we have the point passing through 3, -4, so 3, -4 is located here. And we have the slope is 2/3, so the rise is 2, the run is 3. So to get to the next point, we rise 2 and run 3. And to get to the previous point, we drop 2 and go to the left 3. So let's go ahead and connect those points. There we go. Label it. Okay, that's A. Convert the equation for line A into slope-intercept form. So here's what we're starting with. So we start with y plus 4 equals 2/3 x minus 3. Now this 2/3 on the right has to hit both the x and the -3, so that's a distribution. So let's go y plus 4 on the left, that stays the same. We'd have 2/3 x, or 2x over 3. 2/3 times -3 over 1 will be -2. Okay, and then now I just want to work toward getting x on its own. So, sorry, I just want to get y on its own rather, because I want to get y equals mx plus b. So I got to get rid of this 4. So if I subtract 4 from both sides, that'll bring us to where we need. 4 minus itself on the left is 0. So all that remains is y on the left. 2/3 x stays the same, right? It's not, 4 isn't an x type of thing, so 4 only interacts with this 2. -2 subtract 4 is -6. Alright, so verify the y-intercept from your equation matches the y-intercept of the graph. Looks like it does, so that is, maybe I won't draw an arrow, that is at 0, -6, as is indicated here, and 2/3 right, saying rise 2, run 3. So looks good. Okay. So is there a way that we could confirm that with the equation? We could. So I mean, we could start with this, and well, yeah, maybe we'll just leave it there. So just confirm it visually. Looks good. Okay. Next, for each equation, state the slope and the coordinates of a point on the line and sketch the graph. So here we have the slope is -3, right? We're comparing it with y minus y1 equals mx minus x1. So the slope is -3, great, or -3/1 if you like. And the point, the x-coordinate is -5, right, because it's like opposite. And the y-coordinate is 4. So let's locate that point. -5, 4 is there. And I need to draw from here a slope with value of -3/1. So the rise is -3, the run is 1, and then 1, 2, 3 over 1, and so on. So now I can draw a line here. Try to get that parallel. And just scooch that. Come on. Okay, that is line A. Next, 2/5 is the slope for this one. 1 is the x-coordinate. -6 is the y-coordinate. So let's locate 1, -6. That's there. Slope is 2/5, so the rise is 2. Run is 1, 2, 3, 4, 5. And I can't continue any further because it's off grid. So let's work backwards and see where it should come from this point. So down to right 1, 2, 3, 4, 5. So that's where B will go through. Get that going. So there's B. Next one, slope is 2. X-coordinate is 4, and it'd be, I guess, y plus 0 if you like, so 4, 0. So let's locate 4, 0, that's there. The slope is 2, or 2/1, so to get to the next point, we rise 2, go over 1, rise 2, go over 1, and so on to 1. Let's draw a line through that. So just readjust that. Okay. Good. Maybe I'll put this label up here. So that's A. This is C. And we've got one more. So this looks a bit wacky. So y minus 6 is fine. I know what the y-coordinate is. It should be 6. But what's going on here? So let's maybe rewrite this as -x plus 0. So maybe that's a little bit more easy to interpret. So negative, if I distribute this negative into the x and the 0, that would give me what this is. So the slope then is -1/1, and the x-coordinate is 0. So 0, 6. Alternatively, we could change this into slope-intercept form. So it would be y equals -x plus 6, if you like. So let's locate 0, 6. That's there. The slope is -1. So down 1, right 1. There's, okay, down 1, right 1, down 1, right 1, and so on. Okay, so let's draw that line. That looks about right. I'll just move that. Whoa. Move that. Okay, and that is D. moving on. On the grid, draw a line with a slope of -3/2 that pass through -2, 7. So -2, 7 is there. And the slope is -3/2. So down 3, that's the rise, over 2, that's the next point, down 3/2, that's next, down 3/2, so on. Okay, let's go ahead and connect those. So draw the line, good. State the equation of this line using the slope and the point -2, 7. So express the equation in this form. So I will go y, subtract, my y coordinate is 7, my slope is -3/2, and my x coordinate is -2, so I go x subtract -2, right? I put a -2 in for x1, and subtracting -2 is the same as adding 2. Okay, so there we go. Convert your answer into slope y-intercept form. State the y-intercept and verify it with your graph. So let's just, okay, this is going to be a challenge. So, trying to save time here, but here you go. X plus 2. Okay. All right, so we want to get y on its own, and we need to get it in the form y equals mx plus b, right? Mx plus b. So I don't want to have these brackets here, so I need to distribute this into each thing there. So let's go ahead and do that first. Y minus 7 equals -3/2 x. -3/2 times 2/1 will be just -3, right? -3/2 times 2/1. That'd be -6/2, which reduces to -3, right? Okay, and the last thing we need to do is just get rid of this -7 on the left. So let's do that. The opposite of subtracting 7, add 7. We need to do that to both sides. And that gives us then -3/2 x plus 4. So based on this, the y-intercept is at 4, which you can see is good. So that's 0, 4. That's what we needed it to be. And the slope is -3/2. So that's good. So state the y-intercept is equal to 4 and verified with the graph. Okay. Alright. Long day, I guess. State the coordinates of one other point on the line besides the y-intercept. So let's go maybe 2, 1. So I just picked that off the graph. Right, 2, 1 lives there. State the equation of this line using the slope and this point in slope point form. So y minus y1, m x minus x1. So I put this x and that y in for these 2 points. The slope is still -3/2 as it was before. So I'll go y minus 1. -3/2 x minus 2. Convert it to slope y-intercept form. So what I need to do is distribute this into each the x and the 2. And then I need to get rid of this -1. So let's start by distributing this into the brackets. So we have then y minus 1 is -3/2 x. -3/2 times -2 will be +3, right? -3/2 times -2/1 is, so multiply the top, that's +6, multiply across the bottom, that's 2, ultimately 3. Okay, and we're close. Now we just get rid of this. So add 1 to both sides. So then y equals negative 3/2 x plus 4. And what do you notice comparing C and F? So comparing this one, right, to, what is it, this one, they're the same. Negative 3/2 x plus 4 and negative 3/2 x plus 4, even though I used 2 different points. So notice I used a different thing here. I used 2, 1. And back here, I used 7. So yeah, used 2 different points. So they're different, right? But I ended up at the same slope y-intercept form, which makes sense because it's consistent. It's on the same line. So C and F are the same. So let's see, negative 16, negative 19, does it lie on the line? So what we could do is start with this again and see if it produces the same slope y-intercept form. So let's try. So y minus something equals m, which was negative 3/2 x something. So 16 goes here, and so x minus 16, right? Y minus negative 19, so that will be y plus 19. So now let's see. So if 16, negative 19 lies on this line, I should produce the same slope y-intercept form after some simplification. So let's see if it does. Y plus 19 equals negative 3/2 x. So that part looks good. Negative 3/2 times negative 16 is positive 24. So negative 3/2 times negative 16 over 1. And you can do that in your calculator, right? 2, that would be, I don't know, something, doesn't really matter. So you get 24, positive 24. Okay, and then last you need to subtract 19, subtract 19 there and there. 19 minus itself is 0. So we end up with y equals negative 3/2 x. 24 minus 19 is 5, so not quite, because that is not consistent, I guess. So because those are different, then we can tell it's not on the line. So 16, negative 19, not on line, because, well, these are different, right? We expect b equals 4, and it's 5 in this case, so no good. All right, okay, moving on. Write the slope point form of the equation of each line. So something passing through 5, negative 1, and negative 7, 2. So first off, it would be helpful, I guess, to find out what the slope is. So we can use this to figure out what the slope is, right? Because eventually we're going to have to get to this. We need the slope. So y2, I'll put 2, y1, negative 1, x2, negative 7, x1, 5. So 2 subtract negative 1 is 3, negative 7 subtract 5, negative 12, This simplifies to -1/4, so that's great. And because we want slope point form, I can choose either when I sub in x1, y1. So point is, now I have the slope, -1/4, x, I'll choose this one, so x minus 5 and y plus 1. Now, so that's possibility. Or if I had chose the other one, I could choose this one just as easily, just as valid. I would end up with y subtract 2 equals -1/4 x plus 7. So even though these appear different, if you converted these to the form y equals mx plus b, you would get the same thing. Okay, let's try another one. M equals, you know what, I'll just leave it up to you to confirm that this slope is -3/2, and you could either get this or what would the other one be? Plus 27 equals -3/2 x minus 9. So either one of these would be fine. So I'll just maybe leave it up to you to confirm that that's the slope, and those would be your possibilities for slope point form. Okay, moving on. Write the equation of each line both in point slope and slope y-intercept form. So obviously we can't immediately write slope y-intercept form because we can't see where this line crosses through the y-intercept. This is 5, 1. This is, what is that, 9, 9. Okay. Alright, so we have a point, so we have 2 points. I'll just maybe use this one though. I also need to know what the slope is. So if I go from here to here, I need to rise a number of points. So 1, 2, 3, 4, that's plus 4. The run is 2, so the slope is rise over run. That'll be plus 4 over plus 2, so that'll be 2. Okay, and now we're in a position to do this, y minus y1, m x minus x1. I'll use this point, 5, 1, so I'll go y minus 1. 2 is the slope, I just found out, x minus 5. So there's a possibility for slope point form or whatever. Okay, and then we need to convert this to slope intercept form. So we can distribute that in there, giving me y minus 1 equals 2x minus 10. Get this 1 over to the right, so I need to add 1 to both sides, giving me finally y equals 2x minus 9. So that's your slope intercept form. Okay, next I got this point here, -6, 1. I got this point here for -5. So let's maybe start by figuring out what the slope is. Now you can do that like I did here, or we could also use the equation y2 minus y1, so call that my y2, that my x2, x1, y1, so it'd be -5 subtract 1 divided by 4 subtract -6. -5 subtract 1 is -6. 4 plus 6 is 10. Slope there is negative 3 over 5. Okay, and now we can do point slope form, y minus y1, m x minus x1. So I can put this in. I'll do that. So y subtract negative 5 be y plus 5, and that's negative 3/5 x minus 4, right? 4. So that's your point slope form. Good. And if I want to convert that to slope intercept form, obviously I need to distribute this thing in there. So if we do that, we get y plus 5 equals negative 3/5 x. Negative 3/5 times negative 4 is positive 12/5. Subtract 5 both sides. Y equals negative 3/5 x. 12/5 minus 5. So we do that up here. 12/5 minus 5 over 1. Need to get common denominator. 12 over 5 minus 25 over 5. That'll be negative 13 over 5. So negative 13 over 5. That's slope intercept form. Okay, we're nearly done. Okay, the total cost for 10 books is $80. The rate of change is $5 per book, so that's rate of change is like the slope. State the equation where C represents the total cost and N the number of books. So we would have something like number of books, and then the cost would be like, going up. So we have C minus, okay, and our point here, 10 books is $80, so we have like 10 comma 80. So 80 is my y value, 5 is my slope, x minus 10. So that's point slope form. Convert to slope y-intercept form. Maybe leave it to you to, it's fairly simple, right? Distribute the 5 into each. C equals 5x plus 30. So the 30 right comes from negative 50 plus 80. That gets you there. 5x, go. There we go. Use the equation to find the total cost for 100 books. So n is equal to 100. Just put, or I guess x. I should have had that as an n. Let's just fix that. Minor thing, but n, 5, n. Okay, so put 100 in there. 5 times 100 plus 30. That's going to be the cost for 100 books. 500 plus 30. 530. We did it. Okay. So slope point form of a line is written as y minus y1 equals m times x minus x1. That's on your formula sheet. Slope point form can be used to find the equation of a line when given either 2 points or 1 point and the slope. Okay, the equation of a line may look different when it's written in slope point form because you can choose many points. But when converted to slope y-intercept form, the equation will be the same. Okay, so that's it for me for today. Please try the questions in the practice that correspond to today. So page 372, 4 to 12, and so on. And finish the assignment for the day. And I'll see you next time. Have a good day. Bye.